Hello viewers, this is the video lecture for the topic Gradient Descent Optimization from the 5th unit Neural Networks for the subject Artificial Intelligence and Machine Learning. Gradient descent is known as one of the most commonly used optimization algorithms to train machine learning models by means of minimizing errors between actual and expected result. It is also used to train neural networks. In mathematical technology, optimization algorithm refers to the task of minimizing or maximizing an objective function parameterized by x. Similarly, in machine learning, optimization is the task of minimizing the cost function parameterized by the model's parameter. The main objective of gradient descent is to minimize the convex function using iteration of parameter updates. Once these machine learning models are optimized, these models can be used as powerful tools for artificial intelligence and various computer science applications. Gradient descent was initially discovered by Augustin Louis Cauchy in the mid of 18th century. Gradient descent is defined as one of the most commonly used iterative optimization algorithm for machine learning to train the machine learning and deep learning models. It helps in finding the local minimum of a function. The best way to define the local minimum or local maximum of a function is if we move towards a negative gradient or away from the gradient of the function at the current point, it will give the local minimum of the function. Whenever we move towards a positive gradient or towards the gradient of the function at the current point, we will get the local maximum of that function. This graph showing the minimum cost and the maximum cost, and the line touching the curve is called as gradient, and initial weight in each incremental steps the gradient value will be changing and the weights also changing. So in each incremental step it will find out the minimum cost steps. The main objective of using a gradient descent algorithm is to minimize the cost function using the iteration. It calculates the first order derivative for the function to compute the gradient or slope of the function. Move away from the direction of the gradient, which means slope increased from the current point by alpha times, where alpha is defined as learning rate. It is a tuning parameter in the optimization process which helps to decide the length of the steps. Cost function. Cost function is defined as the measurement of difference or error between actual values and expected values at the current position and present in the form of a single real number. Before starting the working principle of gradient descent, we should know some basic concepts to find out the slope of the line from linear regression. The equation for a simple linear regression is y equal to mx plus c. M represents the slope of the line, c represents the intercept on the y-axis. The starting point is used to evaluate the performance as it is considered just as the arbitrary point. At this starting point, we will derive the first derivative or slope and then use a tangent line to calculate the steepness of the slope. The slope becomes steeper at the starting point or arbitrary point, but whenever new parameters are generated, then steepness gradually reduces, and at the lowest point, it approaches the lowest point, which is called as point of convergence. The main objective of gradient descent is to minimize the cost function or the error between the expected and actual. To minimize the cost function, two data points are required: direction and learning rate. These two factors are used to determine the partial derivative calculation of future iteration and allow it to the point of convergence or local minimum or global minimum. Let's discuss learning rate. Learning rate, it is defined as the step size taken to reach the minimum or lowest point. This is typically a small value that is evaluated and updated based on the behavior of the cost function. If the learning rate is high, it results in larger steps but also leads to risk of overshoots the minimum. At the same time, a low learning rate shows the small step sizes which compromises overall efficiency but gives the average of more precision. Types of gradient descent. There are the types: batch gradient descent, stochastic gradient descent, and mini batch gradient descent. So that's all about the topic. Thank you.